Hello student, in this video I am going to describe an example and we'll try to know what are the required thing to know to solve this problem. The problem we are going to discuss about, that is whiskey analytics. This simple video just talking about an example and we'll try to explore that example. Okay, and let's see what we can get. Here you can see one of us one of us likes single malt Scotch whiskey. One of us means, suppose the name is Foster, likes single malt Scotch whiskey. If you have had more than enough more than one or two, you realize that if you have had more than one or two, you realize that there is a lot of variation among the hundreds of different single malts. When Foster tries to analyze, finds a single malt he really likes, he wants to find another similar ones because both because he likes to explore the space of single malts, but also because any given liquor store or restaurant only has a limited selection. So there is two reasons due to which Foster want to explore that process to find a similar best or similar single malt whiskey, Scotch whiskey, which he likes. So he wants to find other similar ones, but because he wants to find what he likes and he wants to find other similar ones, and both because he likes to explore the space of single malts, whatever single malts are there in the market, or also because any given liquor store or restaurant only has a limited collection. So that is the problem of this scenario. So let's go to the next part of this problem. He wants to pick, he wants to able to pick one he will really like. For example, the other evening, a dining companion recommended trying the single one that is named as Bunna Hawaiian. So one of his friends recommended him that this other brand of single malt is good. It was unusual and very good. Out of all many single malts, how could Foster find other ones like that? Now again, same question arises. So it was unusual. Unusual means because that this is a recommendation from other companion, and also that brand is good one, very good. And out of all many single malts, how could Foster find other ones like that? Let's take a data science approach. So if you go to the chapter 2, the first you should think about the exact question we would like to answer. What are the appropriate data to answer it? Means to answer that, to find the base single malts or the single malts which Foster might like, that solution, to find the solution of that problem, we need to find the appropriate data which will answer our question or answer the question of Foster. Now, how can we describe single malt Scotch whiskey as Fisher's factor? Now, point is that in this scenario, you need to, obviously, if you want to find out the answer of this problem, you need to devise a process where you can create a data set of single malt Scotch whiskies where there will be some features about that Scotch whisky in such a way that we think similar whiskies will have similar taste. Similar whiskey means having similar features of a whiskey, then it will have a similar taste. This is exactly the project undertaken by Francois Joseph Lapointe and Pierre Legendre of the University of Montreal. They are interested in several classification and organizational questions about Scotch whiskies, and we will adopt some of their approach here. So in this book also they try to understand that same problem. They try to explore the same problem. It turns out that our publishing are, it turns out the tasting notes are published for many whiskies. For example, Michael Jackson is well known whiskey, and beer connoisseur who has written Michael Jackson Malt Whiskey Companion, a connoisseur guide to the malt whiskies of Scotland, which describe 109 different single malt Scots of Scotland. So this is a repository. This book is a repository for that 109 different single malt scotches. So you can create data set from that book because that is created by or that is written by Michael Jackson. The description are in the form of tasting notes on each scotch, such as appetizing aroma of peat smoke, almost incense-like, healthy honey, or you can say heather honey with a fruity softness. So because why we are doing this? We are doing this because we need to create a data set. So to create a data set, we need to create the Fisher vectors for any sample. And after creating the Fisher vector, we need to create the data set. And for that, we need to go for the data samples. And for the data samples, here we need some sources where we can gather this data. Here one book gives the data about 109 different single malt scotches of Scotland, and which describes in that book about how that those Scotch whiskies are appetizing, aroma of peat smoke, almost incense-like, heather honey with a fruity softness, like that. As data scientists, we are making progress. We have found a potentially useful source of data. However, we do not yet have whiskies described by Fisher's factors. So till now, till this problem, we do not have a specific Fisher factors to describe a whiskey. Only by testing notes. We need to press on with our data formulation. So our very important part on this scenario is how we can design our data or how we can design our Fishers. Following the Lapointe and Legendre research, it is mentioned here, you can find it in the internet also. Let's create some numeric features. Okay, they try to create some numeric features that for any whiskey will summarize the information in the testing notes. Define 5 general whiskey attributes, each with many possible values. So they try to create these 5 attribute features. So it might have lots of values, possible values, which is 14 values for color. Nose might be like whatever fragrance we can get through our nose. That is one feature. That may be aromatic, peaty, sweet, light, fresh, dry, grassy, etc. That might be 12 values. And what is the body? Body of the bottle. What is the palate? Okay, what is the finish? Means what is the finishing taste? Okay, like that. So they try to given that, or they try to formulate the data following this formulation. They try to give 5 different Fisher factor, or you can say attributes with possible number of values and types of values. They will try to number it 1 to 14 for each of one, so that they can define any whiskey brand in that way. It is important to note that these category values are not mutually exclusive. So here you can see one most important thing here. These category values are not mutually exclusive. Okay. For example, Eberlo's palette is described as medium. That is another brand. Eberlo's palette is described as medium, full, soft, round, smooth. Full, that is medium, means that is the medium. You can see here, that is medium from here. Somewhere from here, there are some values from medium. Then full, somewhere from here, medium, full, and then soft, medium, full, soft. Okay, like that. They try to round, smooth, like that. In general, any of the values can co-occur through some of them, though some of them, like color being both light and smoky, never do. So here, having a brand which color is light and also smoky might never exist, but because they can co-occur, each value of its variable was coded as a separate feature by Lapointe and Legendre. Consequently, there are 68 binary features of such each whiskey. So now you can see here, these values, when the color of a single malt Scotch whiskey is yellow, then we obviously cannot say that is pale yellow. Means that those values are not mutually exclusive. So that is why they does not only concern with these 5 attributes. They exploded, or you can say expanded, the whole attribute numbers to the 68 binary features. Lapointe and Legendre, consequently there are 68 binary features. If you add them, it might be almost 68. I have not calculated it. You can calculate it. You can see whether it is equal to 68 or not, but it might be equal to that 68. But you can see here, suppose the brand or suppose the single malt whiskey is not yellow, then it will be 0. If it is yellow, then it is 1. In that way, binary features were created. So that is done by Lapointe and Legendre. So Foster's likes Bunna Havain. So that is a brand that is recommended by one friend to Foster, and which he likes. And so we can use Lapointe's Legendre's representation of whiskey with Euclidean distance. Now we try to understand the Euclidean distance. Why we are trying to introduce Euclidean distance in this scenario? Because we are going to find a similar one which is similar to that liked Bunna Havain brand. For reference, here is their description of Bunna Havain. That is, the color is gold, nose is fresh and sea, means the scent or accent, and body is firm, medium and light. Palate is sweet, fruity and clean. Finish is not full. Here is Bunna Havain's description, and 5 single malt Scotch is most similar to Bunna Havain by increasing the distance. So here you can see, by finding the Euclidean distance. So we'll discuss about these similarity values, how we can understand or how we can calculate the similarity values in next class. But try to understand what is the significance of these values. So here you can see, this brand has a less distance with Glenglassaugh, which is 0.643, means that is more similar to the Bunna Havain. Like that, we can increase to the 5 most similar to the Bunna Havain, and their color or any other features might be almost similar. So in that way, they try to find the similar whiskies available using that data science concept. So using this list, we could find a Scotch similar to Bunna Havain, at any particular shop, we might have to go down the list a bit to find an one-day stock. But since the scotches are ordered by similarity, we can easily find the most similar scotch and also have a vague idea as to how similar the closest available scotch is as compared to the alternatives that are not available. So you can see how we can approach to this problem. So this is an example of direct application of similarity to solve a problem. So that is why I am trying to give this example, because when we try to understand or when we try to go with the data science to solve any problem, in many times we try to find the similarity values, and the similarity values can be applied to solve different problems, and that is why it is very important what are the similarity value measurements are there. In the next class, or you can say in the next video, I will try to go with few of them to understand better about the similarity values, how we can calculate them, and how we can introduce in different problems so that we can solve this type of problem with data science techniques. Okay, so that is all about in this video. I just want to give you this example. It's a nice one, and you can understand how data science and how similarity values can help us to find the similar Scotch whiskey for Foster. So that's it, all about in this video. If you have any doubt, please let me know. I'll try to resolve it over Google Meet. That's it. Thank you.